Indosaw is India's one of the largest manufacturing company in educational science lab equipments. It has a wide range of equipment for making science learning fun. The ring launcher experiment is an outstanding demonstration of Faraday's laws of electromagnetic induction and also of Lenz's law. A conducting non-magnetic ring is placed over the extended vertical core of a solenoid. When AC power is applied to the solenoid, the ring is thrown off. We will look into the items provided with this experiment kit. First item is ring launcher unit. The unit consists of two parts. The lower part is the base of the unit. The upper cylindrical portion contains a solenoid. This cylindrical upper portion is termed as solenoid tube. These are the accessories supplied along with the ring launcher unit. There is one transparent adjustment collar which fits over the solenoid tube. There is one iron cover which is inserted into the solenoid tube. There are two aluminium rings and one plastic ring. Out of these two aluminium rings, one ring is continuous and the other one is discontinuous by a split. Apart from those items, there is a coil which connects a bulb across its two ends. A power cord is provided as well. An instruction manual is also provided. In the first experiment, we will demonstrate the Thomson's jumping ring. These are the items required to perform the first experiment. Ring launcher unit, adjustment collar, iron cover, solid aluminum ring, split aluminum ring, plastic ring, power cord. Before proceeding to the experiment, please keep these precautions in mind. Make sure that the aluminium ring is not installed into the launching unit to prevent accidental launch. Ensure vertical clearance of area, approximately 1.5 meter to 2 meter, above the unit for the ring's flight. It is advisable to switch off the unit and allow 10 minutes cooling time after each 5 launches. Now, we will show you how to arrange the experimental setup and perform the experiment in steps. In the first step, place the ring launcher unit on stable level surface with power switch button off. Now insert the adjustment collar at the top of the solenoid tube. The position of the adjustment collar can be altered by sliding it over the solenoid tube. Now, insert the iron cover into the solenoid tube. Now, plug the power cord into socket at the back of the ring launcher unit. Plug the other end of the power cord into a grounded wall outlet. Switch on the ring launcher unit. The power LED in the front panel will be turned on. Place the solid aluminum ring over the adjustment collar of solenoid tube. Slide the adjustment collar upward along the tube of the solenoid so that it is close to the top of the solenoid. Before proceeding to the next steps, please check these points very carefully. Make sure that the area above the ring launcher unit is clear. Make sure once again that the iron cover is already inserted into the solenoid tube. Make sure that the aluminium ring resting on the adjustment collar is situated at the top of the solenoid tube. Now press the launch button twice to energize the ring and to launch the ring respectively. The ring will be launched. Don't lean over the equipment while launching the ring. Now, lower the aluminium ring downward a little bit by adjusting the position of adjustment collar as shown. Again, launch the ring by pressing the launch button twice. Observe the change in the height of the launching ring as compared to the previous case. The ring will raise to more height as compared to the previous one. You can fix the aluminium ring at some other heights as well and perform the experiment depending on the available vertical area above the unit. Now replace the solid aluminium ring by the split aluminium ring and perform the previous steps once again. The ring will not be launched in this case. Now replace the split aluminium ring by the plastic ring and repeat the steps to launch it. Again, the ring will not be launched in this case as well. Switch off the unit and wait for next 10 minutes before proceeding to the next experiment. It is advisable to switch off the unit and allow 10 minutes cooling time after each 5 launches. In case of a solid aluminum ring, induced current generated in the ring is in the opposite direction to the current in the solenoid. These two opposite currents repel each other. This is in accordance with Lenz's law. In case of split aluminum ring, no current can be induced in the ring, as a complete circuit cannot be formed due to the cut in the ring. So it would not jump. Plastic is not a conductor, so no current is generated, and hence no jumping effect is observed. Now, in the xenon experiment, we will observe that a current is induced in a secondary coil. These are the items required to perform the second experiment: ring launcher unit, adjustment collar, iron core, coil with bulb, power cord. Arrange the ring launcher unit with adjustment collar and iron core. Insert it into it. Connect the power cord between the unit and the power outlet. Switch on the ring launcher unit. The power LED in the front panel will be turned on. Place the coil with lamp over the adjustment collar of solenoid tube. Press the launch button twice. You will observe that the lamp illuminates. Move the coil up and down by changing the position of the adjustment collar along the solenoid tube. Repeat the previous steps and observe the variation in brightness of the lamp. Maximum brightness is observed at about the middle of the coil. The illumination of the bulb proves that a change in magnetic field will have the effect of an induced electric field, which will, in turn, generate an electric current in the coil. Since the intensity of the illuminating bulb is strongest at the middle of the solenoid, so we can say that the rate of change of magnetic flux is strongest there.